So I'm handing out a project that's going to be due in a week. I'll talk about it in class. It's using Google Docs to do graph some stuff. I'll tell you more about it later, but I think I'm just going to count here instead of walking over there. Yeah. Wrong pile. Okay, so it's 1 o'clock. First thing I want to do is just to tell you, there were a few people that tried to access online last time and there was an issue. And the reason was because I found out that for some reason, which I don't know the reason, this link, which I originally set up, won't record the session. So last week, Wednesday and Thursday, I recorded it and then I tried to post it. It didn't work. So so I created a new session, which is right down here. So that's where you should go to if you're going online, is to go where it says attend class here. Don't go where it says don't go here. Okay. Don't go there. Okay. So go here. And that's the one I'm using right now. And you can see there's Katie Lee. She's online. She actually called me ahead of time to make sure she was in the right place. So if you want to do that sometime, the session is always open. So you can get on, and then you could call me and say, hey, can you get on and make sure I'm in the right place? And then you know you are. Okay, the next thing, just to show you while I'm here already, in the content, you'll see right at the bottom is a new folder called Google Sheets Project. So this is what I just handed out, which is the assignment. It's a Word document. And then there's a video that shows you how to do it. So the description is, it's not it doesn't have a huge amount of detail, so you might at least want to look at those just to make sure you're doing it correctly. I do want you to use Google Docs and not to use Excel. Oh, you didn't get one? Oh, that's his. Okay. Yeah, there you go. Oh, by the way, here's something else. Well, going up there, I'll get it to you later. And so that'll be new next Wednesday. Remember, we're having it. Pardon me? Yeah. So let me just give you a little bit of information. Let's just talk about the project. I'm going to work through an example, not this example, but another example that I'm just going to make up and show you how to do it. Of course, if you've never done it before, that won't be enough instruction. But the video goes through these exact numbers, so you don't have to worry. You'll be fine. Nobody's had any problem with it in the past. Yeah, so what will happen is you will email it to me. I'll show you how to do that. Pardon me? Use those numbers. But I'll show you how to email it to me later. So let's just talk. So there's 3 things I want to do today. One is to just go through some example graphs that I'm going to randomly pick from the internet based on maybe a topic that you guys are interested in. If nobody says anything, I'll think of something randomly, and just to describe how you interpret graphs, those kinds of things. But so I'm going to go through an example here. Don't try to write anything down because you'll never keep up with it. So when you get into, when you log on to your email, if you go into Gmail, then you can access the Google Sheets and all these other applications through this little waffle thing. And so we're going to go down to Sheets. And so what this allows you to do, these are the two assignments, which I'll just show you briefly at the end. So spreadsheets are ways to create tables of data, but it also allows you to create plots, charts, and that's what this is all about. So the way you create a new spreadsheet, you just click on the little blank thing. So this is what it looks like. It's a bunch of what we call cells. So you can move your cursor around, or you can just use your mouse and click on a cell. And the cells have a certain way of designating what cell they are. This cell right here would be called A1. So this is the first, the letter is the column, and the number is the row. So this would be cell A1. I'll just write in A1 just for the heck of it. So that's A1, that would be A2, and so forth. This one here would be B1. Okay, we can delete those. I'm going to zoom in a little bit for right now. So what you're going to do in this project is you're going to enter some data. And so I'm going to make up some data here, which is going to be year and enrollment. And so I'm going to just do like 5 years. So we'll pick 2005, 2006. So all you have to do is just enter the data and push a return, and it will behave as you expect. And let's say the enrollment in a class is 35, 31, 46, 52, 60. Okay, so those are the number of people enrolled in the class. So there you have a table. Now, and so, you know, for your project, you're going to enter the data shown here. And notice that I've included, just like in the project, I've included a descriptor of what the column represents. So in my case, I have year and enrollment. Here you have age versus savings, and animal versus harvest. Okay. So to put a chart or graph into your spreadsheet, what you're going to do is you are going to do this. And I'm going to have to zoom out just a little bit. Otherwise, I can't see what I'm doing. So there's an insert command. You can insert all this. You can insert rows and columns if you want to smush something in there. The one we're doing is chart. So for the project, we're going to insert a chart. And so it actually automatically decided to pick the columns that you want to pick. It picked, so this little designation, sheet 1, exclamation point, A1 colon B7, what the heck does that mean? Well, what that means is sheet 1 is let me just close this for a second. Sheet 1 is the sheet that I'm looking at. The way spreadsheets are made up, you can have multiple spreadsheets in one file, and right now we just have one leaf, but you can have multiple leaves that have like a little tab on the bottom. So this is sheet 1, and what it's saying is the data is in these cells. It's from A1 to B6. Now if I highlighted it, it would, I mean, I don't have to highlight it because that's the only information that's in the spreadsheet, so it's going to figure it out. But if I needed to tell it to do it, I would highlight the data. And then I'm going to insert the chart again. Insert chart. So it makes some assumptions. It decides that it wants a particular kind of chart based on how the data is presented. So does anybody know what, so we're going to look at different kinds of charts. So this is something that's in section 4. So the first chart that you see, the one that's on the right and highlighted in the left, is what's called a scatter plot. And what that does is it basically puts a dot where the data is, the two pieces of data. So what this, if we read this graph, I don't know why that happened, you can see enrollment versus year. It already figured out what the axes were, which is nice. So there's 35 people in the first year, 28 in the second year, 46. Actually, that's probably more like 30. I was looking at the scale. So notice the scale is every 10. So looking at this, it's somewhere between 25 and 35. 31, okay. So it looks a little bit more than half, so 31 sounds good. This is probably 46 to 47. This one's probably 52. This one is 60. Okay, so I'm just trying to use what I'm doing is I'm looking at the data point and going over here and trying to figure out exactly where it fits. So that is called a scatter plot. And if you're an engineer, that's the one you use most of the time, because you're looking at data. You run some experiment and you're changing something. You're purposely varying something here, and you're measuring something here, and then you want to see what it looks like. Actually, we did one in physics today. I might even show you that later. Okay, actually, I'm going to take my thing here so I can just go over here. So the next plot, it's the same data, but instead of putting a dot, you draw a line between the points. And you can see when I stick my cursor over top, it tells me the X value 2007 and my Y value 46, and there's 31. That's called a line plot. We're going to skip that one, and that's the third kind. That's called there's different names for it, vertical bar, column plot. So I'm showing in column. And so this is the one you would use mostly for non-scientific data, surveys. The last time, I think about, if you remember back, well, you probably didn't pay attention to it, but I did, the Republican primaries, and you had 15 people running, and they would show, what the poll results were for each one of the 15 people. They'd show it as a bar. Again, it's the same information. It's just shown in different ways. Those are the three kind. Well, actually, the fourth kind is a pie chart, which this really is not appropriate for pie charts, so we're not going to use that for right now. Okay. So in the project, I tell you to do a line plot, a column plot, a scatter plot, and a pie chart. So those are the four kinds of plots. And these are the recommendations, but you get more choices if you go to chart types. So these are just more of the same thing, just variations. For example, this one here, it puts a line in, but it kind of puts a curve to it instead of straight lines. The one that we want to use, one we're going to use here is just the simple column plot. So the kinds of things that you might be looking to read off of this are, just the values. But you can get the values off of a table. So, if you're just looking at numbers, if you just want to get a number, it's much easier just to look at a table. Here you're looking for trends. So notice the enrollment in general is increasing. So that's good for whatever that is. Sometimes you want to see which year you see the biggest increase. So if you looked at that, which year, from what year to what year? Timber. So from what year to what year is the change the biggest? Just visually. Don't even look at the numbers. Just look at what we're looking at is, this distance versus that distance versus that distance. Oh, you can't see it? So again, we're not looking for the numbers, we're just looking for that. So this is one, right? Yeah. So that's 2006 and that's 2007. So, hey, James. So, you could say from 2006 to 2007, the change was the biggest or something like that. One thing that's a little tricky here is the scale starts at 25. So we'll talk about that in a second. So you can make further customizations to the graph by clicking on the third tab. So we could change, you can change the title, so it says title right there. So I'm going to say that's English class enrollment history or something like that. And you can see it updates that. Sometimes they put a legend that you don't really need, so you can get rid of the legend if you wanted to. You can change the fonts. These are a little small, right? So you guys are having a hard time reading those. So we might come in here. If you go down, first you've got the title, then you have the axes. This is the horizontal axis. This is the vertical axis. So I see those are pretty small, so I might go over here. I'm on the horizontal axis. I'm going to make it bigger. Make it to like 15. I'll make it bold. If you want to go to the vertical axis, you click vertical, choose the same size, make it bold. You can also change the numbers size here if you want to do that. So this is the size of the title. This is the labels, so I can make those bigger as well. That's the vertical axis, horizontal axis, make that big. So that's much more readable, right? You don't want to make, you want the labels to be big enough that you can read them, but not so big that they're obnoxious or anything like that. You can change colors, fonts, just like any spreadsheet, any kind of word processing or any kind of thing. And once you're finished, then you say insert. So I just zoomed out, insert. And that puts the graph into your spreadsheet. Now I'm going to ask you, and again, this is all on the video, so don't worry. He's like, this guy's going so fast. I can move the image to its own spreadsheet, so it's bigger. Notice what happened is this created a new tab. So there's a tab for the chart, there's a tab for the data. So that's the gist behind. You see, it's not that hard. Once you know what you're doing. So I'm not going. I'm just. We've talked about the 4 different kinds of graphs: scatter plots, line plots, column, and pie charts. Yeah, let me show you. So I'm going to show you what the project looks like when it's done. Okay. If you want to go back and look at your files, there's this little green thing here. So these are the 2 projects that I'm assigning, so you'll see what it looks like. And again, the video shows exactly what. So there's my data. It says data. That's my column graph. That's my line graph. So it hasn't changed yet. I'm not sure why it's not updating. So my thing is frozen up. There's the data. There's my line. Okay, finally did it. There's my line plot. There's my scatter plot. So you're going to make the 3 graphs. And the question about emailing it to me. So it's pretty easy. Again, it's in the video. You go File, Email as Attachment. This is important. Make sure you change this. It's in the video. Change it to Excel. Otherwise, I can't see everything, and I can't make changes. You'll put my address in there, which is in the video, and you'll send it to me, and I'll get a copy of it, and then I'll look at it. I'll grade it. Okay, so that's the basic idea. And the second part of the project looks like about like this. And you have the data, and then you have the pie chart. And then you'll email it to me. The video is about I did it yesterday just in case they made any changes to the software from one year to the next. It took me about 30 minutes to do the video. So it'll probably take you, if you already know how to do this, it'll take you about 30 minutes to do probably. If you've never done a spreadsheet before, it'll probably take you an hour. So just so you know how much time to build into your day. Let's do next Wednesday at 11:59 p.m. So just get it into me before the end of the day. If you need any help, just come see me. While I'm thinking about it here, I'm going to eject this drive, and I'm going to give it to Jackson, right? I think it was Jack. Who was it? Yeah. I'll bring it to you. You don't have to come. So anyway, that's the project, just so you kind of have a general idea of what. Okay, so that's the first thing I wanted to do today. The second thing is we're just gonna. So anybody have any random things that they're interested in? We'll try to find a graph, and we'll just look into the graphs and see if we can interpret them. Anybody want to? Sports, cars, music. Okay, let's look at Broadway shows. So let's see if we can find any graphs to do with Broadway shows, like attendance or something like that. That would be good. So apparently this is graph of the past. It's something to do with, I don't know exactly. Let me go visit the page, see what it is, what the okay. Let's look at the Broadway grosses over the past 30 years. So that's what it is. So this is the amount brought in through Broadway shows starting in 1984 to 2013. So what's the first thing we can say about the amount of money brought in for Broadway shows over the years? Yeah, it's growing. Does it look like it's growing at a fairly constant amount? Meaning each year, does it look like it's approximately the same, higher than the last year? Yeah, I mean, you do see some cases here where it went down. Anybody might know why that went down? Bad economy. Anything happened in 2001, 2002? What's that? In New York City? What's that? Yeah, 9/11. Okay, so 9/11 was in 2001. So that's probably a reflection of just whether people didn't feel safe going to New York, or whether they, I mean, Broadway is far enough away from downtown that it wouldn't have been directly affected by the towers. So that's a little bit there. How about, anybody have any idea what might have happened there? What happened in 2008, 2009? I know you guys are too young to know these things. What's that? Yeah, it was the collapse of the housing market and the recession, so less money to spend. So you can actually explain those. Does anybody know what graph this is of the four that we talked about? Line graph, yeah, it's a line graph. And so notice they do, let's look at the scale. So they've shown, this is 84, 85, oh, why that does that? This is 84, 85, 85, 86, 86, 87. So there must be, it's probably, I guess that's what it is. Yeah. So I don't know what, if that run, it probably doesn't run from January to January. It's probably from June to June. That's why there's some, it's probably some fiscal year. But, yeah. I'm trying to remember the first time we went to a Broadway show. It was when Jennifer was a junior, maybe, in high school, 1998. So that was the first time we went. It was about then. What's that year you were born? Yeah, so we went, the Allegheny High School's choir used to go on a trip every other year. So that was, we were chaperones. That was fun. Oh, did anybody sing in the choir in the high school? Oh, you didn't have one? Oh, yeah. I was going to brag about my daughters, but there's a, you know, they have the district choir competition. I'm still going to brag. So there's district choir, which you may have heard about. You try out for district choir and you go sing in the district area. So my older daughter, Jennifer, she made district choir. And then they have a district choir. They have a tryout for state, all state. So she made it all state. That was pretty cool. Yeah, it's a big deal. So so that was pretty exciting. If you've ever been to an all-state event, it was like, man, especially if you're a singer, the music they do makes you get shivers. It's just so super duper. And they do, especially when they do spirituals like that, those really sound good. So my older daughter was, she's a type A personality. So she practiced and she, you know, she memorized the music that was being for the audition. So then my younger daughter, she's 4 years younger, Heather, she was in the choir for 1 year. And so she made district choir as well, and then so she tried out for all state, and she didn't practice, and she actually has probably better pitch than Jennifer does, but she made all state too, so that was pretty cool. So we went to see her too. Anyway, so much for bragging. Okay. So you've got the only thing, you know, they've got dollars here. You might put an extra, you might, you know, put, even though the title kind of tells you what the axis stands for, you, and the obviously this axis is years. It's not always obvious. Okay, so let's try something else. Find another kind of graph. Oh, that's pretty interesting. So this is, let's see if we can figure out what it is. You might not be able to read everything. So the blue color is gross ticket sales in dollars, which is this one. Red is total attendance. Green is average paid admission. And purple is capacity. So one thing you might compare is the red versus the purple, because that tells you what percentage of seats are actually being sold for them. And you can see, well, right now, what would be the show that's probably has the highest percent attendance as far as you know what it is. It's Hamilton. It's Hamilton. So back here you can see this was in 2013. The most popular show, as well as the one that has the most utilization of their seats, is Lion King, which is, I saw that. That was good. Wicked, I saw that too. That was good. That was awesome. Yeah, it was awesome. Book of Mormon, which I have not seen, but I would like to see that. Yeah. Kinky Boots, Motown the Musical, Spider-Man, Turn Off the Dark. And you can see as you, you know, as the shows are running longer and longer, or just in terms of their, what you want to call it, popularity, or their staying power. So Mamma Mia, that was good. We saw that too. Chicago, that was good. Saw that. But of course, after you run for a number of years, then you start your ticket sales go down, and you know, it becomes less profitable. I'm just checking to see what the not so good ones were. I haven't seen those. But it's a more complicated bar graph. It's kind of a three-dimensional bar graph. It is a lot of information. So, you know, in this case, it's probably too much information. You want to make sure your graphs have enough information, but not too much information. It's just like when you've done PowerPoints. If you've ever done PowerPoints, you know, they say don't put too much information on a single slide because it's just too crazy. So this one actually is probably a little bit too busy from my perspective. See if we can find a pie chart of some kind. There was a pie, but it wasn't very much. Oh, there's Willy Wonka. Oh no, what is that? No, that's not Willy Wonka. Okay, let's find another one. Yeah, that one's got a lot of stuff on it. Okay, let's look at this one. Huh. Trying to figure out when this is. Must have not been this most recent one, I don't think, because I don't see Mr. Donald in there. But this is a horizontal bar graph. It just presents the same information as a vertical bar graph, just in a different orientation. And so one of the advantages of this kind of graph is that you can put these percentages, and if you had it vertically, it might be not as easy to present. A lot of times if you've got the descriptors are long, it would be hard to put, you can't put them horizontally together, you'd have to put them in an angle. So you usually use these kinds of graphs when your descriptors may be more complicated than a vertical bar graph, but the same kind of information. You can pick up you know, the relative size of each particular candidate relative to the other ones. So it's just, you know, graphs are just a way of presenting data that allows you to interpret the data more easily. I'm looking for a pie chart. Oh, there we go. That's a good one. That's not what I wanted to do. I wanted to view the image. So again, because of all the, let's see, who's in this one? Still don't see Donald. Oh, Ryan's in there. What is that? Oh, it's 2016. That's weird. I don't know where. Anyway, you can see it's very similar to one that we looked at the other day. I think we looked at the pie chart. You've used different colors to represent the different candidates. You've got the key over here. You have to have a key so you know what each color stands. You wouldn't want to stick the name in each little slice because the orientation would change, and also it would just be too busy. So you typically have some kind of a legend over on the side, and then you have the amounts. But you can visually, you could say, you know, without looking at the numbers, you can say this probably is the largest percentage, and the smallest one would be this one. So again, you can do it visually rather than having to look at the numbers. And you know, looking at numbers in the table are interesting, but you don't really get a good visual feel for the relative sizes of each element. And in your interests of equal opportunity here, those are busy. You see these a lot nowadays. So what this is the percentage of voters, and this must have been last year, who were supporting various candidates. You see they're coming together because ultimately they did come very close to each other. Do we have any Bernie fans in here? Yeah, okay. Still vote for Hillary though. You don't want Trump. Okay, sorry. So you know where Trump's going today? Anybody watch the news? What's that? To his grave. No. So yeah, Donald Trump supposedly is flying to Mexico to meet the president of Mexico. So that'll be in yeah, I don't know what's yeah. Yeah, you're actually a good demographic relative to my political leanings because young people tend to be more liberal and tend to be more Democrat than Republican. It's just my contemporaries that I. What's that? Oh, that's right. Who are third? Johnson and what's her name? Jill Stein for the Green Party. Pardon me? Yeah, it's probably still not enough. But yeah, there are the other two parties. We don't want to forget that. I have voted the third party before, so. So actually, so there were elections that I considered voting because I didn't like the two candidates, which a lot of people don't like the two candidates now. But in that case, both candidates were didn't stand out from each other. In this case, from my perspective, one candidate I definitely don't want to be president, so I'm not voting for third party this time. I'm voting to keep a certain person out of the White House. Yeah. Okay. So anyway, this is a line graph, and it's actually, you notice it doesn't have straight lines. It's kind of a curve. It's kind of a curve fitting type thing. Ultimately, though, yeah, the lines got much closer together. Who knows? Given another couple of months, it might have crossed over. Actually, to be honest, I watch. I'm not going to tell you which network I watch mostly, but it was a network that had Bernie Sanders on a lot before he was presidential candidate. So actually, I knew about Bernie before most other people knew about Bernie who watched that particular network, and so I like Bernie too. About Bernie? No, I have not. Okay. Yeah, if out of James knows, out of class, I'll talk politics even more. So just if you want to. Okay. 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 Let's think of something else to look at now. What else I'm going to look at? I was thinking, why did these things pop in my head? I don't even know. So I'm not. I always worry sometimes about what I'm thinking. Someone say something else besides what was the music? What's another thing you guys like? Music, just music in general. We'll say music, sales, chart. And I don't have it on images, so I need to do that. Ooh, that's kind of cool. Oh, that's an interesting one. So this is it's kind of like a line chart, but it's a filled-in line chart, which you can do in Excel. I mean there, but you see how the different media have changed as the years have gone by. And it only goes to 2009, so obviously it's not reflecting things. But you've got 8 tracks, vinyl, then you've got cassettes, CDs, videos, digital. So you see the precipitous decline in total sales. Again, you guys were too young, but when Napster was out, Napster, everybody heard of Napster? Napster was a file sharing or music sharing site, but it wasn't really legal. And so people, what's that? Okay. So yeah, I remember when people were downloading all that stuff from Napster. I think I downloaded a few, but I was pretty good about it. I wasn't that bad. So what you can see from this graph is just how the different media, how they change, because it's interesting how it boomed with CDs. So the amount of music sold, I'm not sure what that's a result of, because you can see how music, that's when music was crap right there. Nobody wanted to buy it, just kidding. That was hair bands or stuff like that. That was the 80s. Which is funny because I have no recollection of music in the 80s, because that's when we had our children when they were young, and we listened to Raffi and Joe Scruggs and all kids music. And then this was actually late. That was when music got better. I remember my daughter. She liked Green Day, so I listened to Green Day. That was good. That was actually better music. Okay, but you can see how things change. You can see the decrease in sales. So how do people make money in the music industry now? Because it's not selling records. Yeah, it's more ticket sales. So again, there's no Access title because they have dollars, and there's no title here because it's obvious what that is. There's a title describing it. So that's kind of a nice, I like that one. Anyway, that's all I'm going to talk about. We're just, we might put some up during the semester of some different ones, but I don't want to belabor the whole thing. I do, I got into this country music phase, and mostly because that was the only thing that was on the radio. And since I got my smartphone, I have transitioned away from country music. I don't know if that's good or bad. I like Keith Urban and Kenny Chesney and that stuff like that. So what I do now is I listen to the BBC. And it's a local radio station from the area where my family's from. And they play a lot of 70s, 60s, 80s, kind of all very much, a lot of variety, which is kind of nice. I like that. So that's my latest thing. I'm listening to old music again. Okay, so let's just open up section 4 here, and then I think I've just got a few problems from section 4 that I'll assign. We're going to move on to chapter 2. Remember, the test is the 12th. So this is, oh, that's last year, okay. Yeah, more stuff, more graphs. See if there's anything interesting here. Yeah, so I'm just looking through these things. This is a plot of SAT score versus first-year GPA. So as you would expect, people who have higher SAT scores tend to score higher to get an average GPA, but the interesting thing is just how much scatter there is. These are all individual data points. This is a curve fit, a best fit to the data, which has a slope. So if you go from 1,000 to this, so these are pretty smart. Well, this must be the new SAT because the old the old SAT was 1,600, wasn't it? So these apparently are smart guys to start with, but going from 1,100 to 1,600, you're going from a 2.5 to almost a 4.0. But within this range, there's a huge amount of spread of the data in that direction. So it's not just intelligence or how well you did on the SATs that show how well you do. It's how hard you work, perseverance, those kinds of things. So that's called a scatter plot. We talked about those. What was this one? This is interesting too. This is another scatter plot showing mortality per 100,000 people versus the median household income. So as you would expect, if you live in a country that has a higher household income, the mortality rate is much lower. And if you live in a poor country that has a lower household income, your mortality rate is higher. But again, within a particular household income, you have a huge spread. So there are things, just because you live in a country that has a low medium household income, probably Cuba is an example, which I'm just guessing, just because they seem to have a pretty good healthcare system there, considering the amount of money, how poor the country is. And then you have other countries, probably even us. We're probably fairly well. We've had pretty good mortality, but for the amount of household income, we're probably not the best that there is. Okay, this is another interesting one. So this is a pie chart showing you how the average family pays for college. The average percent of total cost of attendance paid from each source. So 30 on average, this is on average, 37% of college is paid by the parents' income and savings, 10% by the parents' borrowing, 14% by the students' borrowing, 23% by grants and scholarships, 9% student income and savings, 7% friends and relatives. It's nice to have friends and relatives help you out. Okay. Okay, another interesting one. I found this interesting. This was the percentage. So these are people who are applying for medical school, and each part of the pie chart says, I guess they talk to admissions officers for medical school, and they ask them, which is the most important? Can you rate how much each one of these things on your application helped them get into medical school? So what we see is that the largest percentage, there's actually three things. What is it? The interview, how you come across personally, your cumulative GPA. Actually, that's only 10%. Your science GPA, that's big. So you could be you could be poor in English, but still good at science and math probably, and that helps you out. Your GRE or MCAT, so that's pretty big. Letters of recommendation, actually surprisingly small, probably because most people, I've written letters of recommendation. Do you ever ask anybody to write a letter of recommendation that's not going to give you a good recommendation? That does happen sometimes. I've had a few people I'm like, don't really want to I can't really say anything good about you. No, not. I can usually say something good, but nothing to do with academics. So it's just interesting. Interesting that you can fail. Your overall GPA is not as important as your GPA within science and things like that. Okay, that's the last one.
So your assignment for verifying that you've watched the video is go to Google and then click on images and then search for let's say bar graphs for something. So whatever you want to choose, bar graphs for pizza. So it's your choice. And what I want you to do is then look at these, pick a graph out. So I'm going to read my favorite pizza toppings. And if you click visit page, you'll actually see the page that this particular graph is on. And so you can see, here's my favorite pizza toppings. Now what I'm going to ask you to do is to copy that to the discussion for this particular class. So the way you do that, let me just explain. So you click on the menu bar and it'll highlight everything. You push Control and then C, or you could push right click and copy, either one of those. And then once you get into your discussion board response, you can just do Control V or paste, and then you'll have that in there.
So that's the homework. It's pretty much just looking at graphs and answering questions. So just what we've done today. There's also your assignment, which I need to give to James because he wasn't here. And because I'm making the Google Docs assignment next Wednesday, I'm going to give you until the test to finish this one. So it's the Monday after that. I'll put it in Blackboard so you know. I'll give you a little extra time. That's one bad thing about having grandchildren. It's not really one. It's not bad. When we go to New York, we don't get to see any shows anymore. We haven't seen a show since they were born. Yeah, that's the assignment. So that's still due. That's due next Wednesday. So the other ones, the problems in the book, are due at the test. Okay, so we're going to move on to Chapter 2. So let's do that. So Chapter 2 and Chapter 3 are similar in, oh, I'm sharing, good. By the way, if you ever watch online and I'm doing so you can't see the screen, if you raise your hand, it'll go ding, 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 so that'll remind me that I'm messing up. Yep, okay, thank you. So, yeah, so it's Chapter 2 is what's called set theory, and Chapter 3 is logic. So I'm going to warn you, the next lecture two are a little dry because you've got to introduce terminology and things like that. So I apologize, but sometimes you got to do that. Math can't be all as exciting as it usually is, on the edge of your seat. So the first section is just symbols and terminology. So since we're talking about set theory, we have to talk about what a set is. And where the heck, where is set theory important? Well, it turns out if you ever do computer programming, you'll see a lot of things that are applicable from set theory into setting up data arrays, all the data that's stored in computers. Like if you go shopping online, you've got, how do they come up with these websites that have all the prices and the information, like Amazon? It's probably just set theory for, people who are into set theory probably love Amazon, just how you manage all that data. So a set is just a collection of objects, which can be numbers, can be letters, can be names, can be pictures, anything. So it's just a collection of objects. So let me put this on one page and put my little, I'm going to hide this so you don't get carried away. So to designate what is a set, we use either square brackets or parentheses. Actually, I don't know if about that. That's actually not true. Why did I put that up there? Like, oh, that's not true. Okay, so so let me explain what it is. So you can still write those down, but like, why does he tell us that if he's wrong? Okay, so you used to using these in math to use parentheses to separate mathematical equations, to emphasize, to group stuff. It turns out that when you're when you're dealing with sets, you use these kinds of brackets. So it kind of looks like somebody's nose. You think you like that? I did them very nice and slowly so that they look good. Yeah. So we use these brackets, and you can find them on your keyboard. They're actually just above the little square brackets. Well, I'll show you where they are, because I'll just show you what they look like. So let me, so here's my, so they look like that, and like that. So there they are. Now I've got something in my set. This actually was an empty set. It's a set with nothing in it. You might say, oh, he's being smart. I was going to say something, but smart Alec. But that actually is a real thing. It's a set with nothing in it. It has a special name, which I'll tell you later. So what we're doing is we typically use capital letters to represent the set. So it's just like normal, like algebra. We use letters to represent things. So for sets, we use capital letters. So we're saying the set is equal to this grouping of elements. In this case, the elements are letters. So this set consists of letter A, letter B, letter C, letter D, letter E, letter F. So it has 6 elements in the set. So I think that's probably something I'll define later. Elements or members, those are the things that are actually in the set. Now I'm going to ask a question here, which you may not know the answer to, but I will tell you the answer. Oh, wrong. Sorry. Here. Pardon me? Yeah. Well, you can hold off, and you can decide whether you want to put it in there. Okay. So notice, so what's different about the two things that I did there? Alicia. Oh, somebody said order. Yeah, so they're different order. So the question might be, are those different sets? Is that they have the same letters, they're just different order. Well, the answer is no, because a set, as long as you have the same elements, it doesn't matter what order you present them in. So that's different than a lot of things where order is important. Here, order is not important. So we can say that these two are true. It's the same thing. This is the same as that. We only do it that way just because it's alphabetical, but there's nothing special about alphabetical. But as long as one set has the same elements, you can map, you can say here's A and there's an A and there's a B and there's a, as long as everything's the same, the elements are the same, then the sets are the same. So it can be letters, it can be words if you want to put words in there. Okay, I see what it's saying. Okay, that's reminding me what I'm supposed to be doing here. So there's a couple of ways that you can represent sets. One is just by listing the elements, which is what I've done here. There's two other ways of doing it. One way, the other two ways are just to write out what I just said, what I'm showing here. So I'm going to write it out. I'm going to use a descriptive sentence to describe this set. Also, I would say set A is the set of all letters from A to F. And I probably could, I'm going to put a little small, lowercase. Okay, I had that there because that's what this lowercase. All lowercase letters. So that's another way of describing a set, just by written words. And one of the things you need to learn how to do is to take a written description and then make it a list description, which is what the first one is. So that's the second way of describing a set. So that's called, I don't know what the heck it's called. It's just called a description. There's an actual word for it. That's why I just say words over here. So that's one way. This is the same set, just described in a different way. The third way, it does have a special name. It's called set builder notation. And the way that would be is you would say you'd have A equals, and then you have the bracket, and you put X. X is X. So it's like the previous one, except it's just got a few extra bells and whistles on it. So we have X, and we have this little colon, and we put it in brackets, curly brackets. And the way you read this is A is the set of all elements X, such that X are lowercase letters from A to F. So there's some implied words that go along with this. So let me see if I can write it out. So this is how you would read it. A is this the set yeah, now I gotta remember how to say this. Is the set of all X such that, that's what the colon stands for, such that X, and I'm not sure if this is grammatically correct. I should know if use is or are. X are lowercase letters from A to F. I don't need that because that's, so that's how you would kind of read that particular mathematical description. A is a set of all X such that X are lowercase letters from A to F. such X, such that. I don't know, what did I say? I'm not sure what I said. Yeah, you don't really need to worry about it. You don't have to worry about getting all the letters. What you have to do is, if you're given a description of the set in words, you should be able to come up with the actual elements and put them in brackets. Or you're given the notation there with the X:X, and you say, oh, that means that I just need to list whatever they're describing. That's the basic idea. But as far as remembering the exact words that go along with that, it's not that critical. Okay. Yeah, we already talked to so these individual items in a set are called the members or elements of the set. So the elements and members are individual items in a set. So A is an element of set, lowercase a is an element of set A, lowercase b is an element of set A. Or you could say C is a member of set A, and D is a member. You can use either word. I'm not sure which one I use more. I use them interchangeably, or it depends on how I feel that day. So that's pretty much it from a notation standpoint. Now what we'll do is we'll do some examples where we'll have one description and try to come up with the other two descriptions. I think there's anything else. Let me think about this. Okay, let me see what I got next on my slide here. Okay. So it's such that. So that's and to answer your question, it's the set of all X such that X is whatever. In this case, A is the set of all X such that X is the first 6 letters of the alphabet. I used is in that case. So what we're going to do now is we're going to look at an example in the book, and I need to erase the answers here so we can, this is one of these matching things. Let me zoom in a little bit more so you can hopefully see it better. There we go. We got to cut a little bit off. So what we're trying to do is, on the left-hand side, we have the listing notation. We have the set builder notation. Over here, we have a written description of the set. So we want to match the left and right-hand columns. So let's just start with A and see if we can match it up with 1 through 8. So what is the set of all even integers? So look at all those 8 and see if you can find one that looks like all even integers. If you remember what integers are. If you don't, well. And also, while we're at it, when you use these little dots, we talked about that the other day, I think, when we were talking about something or other. But anyway, these little dots mean that it continues on. So this would be 3, 5, 7, 9, 11. This would be 4, 6, 8, 10. And if the dots go on and then there's a bracket, that means it goes on forever. So this particular set has an infinite number of elements, and this goes all the way to negative infinity. So that's what those stand for. Okay, so now I'm going to call on somebody here. So Justin, wake up. So what do you think, which set on the left is the set of all even integers? If you don't know, just guess, and I'll tell you you're wrong. Just kidding. You want to phone a friend? Okay. Okay. Is Jackson going to help you? So what? 5. No. Sorry. How much you get? Did you know? Is it 6? Yes. Okay. So that's correct. So number 6 is the set of all even integers. So integers, remember, they can be positive or negative. And even, we know, 2, 4, 6, that's something you should know. 2, 4, 6, 8, 10, 12, 0 is even as well. And so you can have both negative and positive. So that set matches up with the description. Okay, so let's write that down. So that, and this is some problem in your book. I forgot what number it is. I think it's actually, well, it's 1 through 8. So you can write this down if you don't want to look at it later. So that's A. Oh, no, yeah, that's right. Okay, let's go to the next one. The set of the least 5 positive integers. That's what the I stands for. So let me see who I'm going to ask here. Harmony. 5 least positive. It means the least positive just means it's the positive numbers that are closest to 0. It is 7. Good. I mean, some of them you can use process of elimination because some didn't only had 4 elements. So obviously this one's not going to work. Well, actually, yeah, the least. That's right. Okay, I was make sure I did that one right. Okay, sounds good. So 7 is B. C is the set of even positive integers. Let's see if there's any more here. Oh, less than 10. Oh, sorry. Yeah, that's probably why you're asking me the question. I didn't show enough of the screen here, so let's fix that. Okay, sorry. So the actual second one was the set of 5 least positive integer powers of 2. Okay, that's a different question. So let's do that. So the powers of 2. So it'll be 2 to the first power, 2 to the second power, 2 to the third power, 2 to the fourth power, 2 to the fifth power. So which one do you think that answers? It's not 7. 5, yes. I was going to say Justin because that's what he picked earlier, but no, I'm going to. Okay, so this is B. Okay, make sure to slide it over. The set of even positive integers less than 10. Who am I going to ask? I'm trying to remember names without looking at the sheet. I'm not doing very well with that. So let me look at the sheet because I know who they are by the sheet, but I still haven't got them memorized. So yeah, don't do that. No, because that'll just make it so I don't remember them. And I also need to. Carrie came in, right? That's Carrie. Yeah, gotta make sure you were late, but we'll make sure you came in. Who was I going to ask? Oh, Miranda. I was going to ask Miranda. So C, which is the set of even positive integers less than 10. Pardon me? Oh, they're in your book. Oh, you got one with answers in it, huh? Oh, you got a good book then. Oh, okay. I didn't know they are they actually in the book. Oh, in your book, you must have got an instructor's edition or something, or they write them in. Oh, wrote it in. Okay. Well, you can still give us the answer. Maybe they're wrong. Number 8. Yes. Why not number 7? Right. So people make that mistake. They think less than 10. They think 10's included, but 10 is not included. So it's C. So I'm going to answer the rest of the questions because we only got 3 minutes left. So D, the set of all odd integers. So this is all positive and negative. So this would be D. The set of all negative integers. Okay, that's all it says. So this would be E, the set of all negative integers, because 0 is not negative, and this is representing going -1, 2, 3, 4, continuing. And if you don't disagree with me, let me know, because I could be getting the set of odd positive integers less than 10. So that would be this one. Odd positive integers, yep. This means the null set, which is this one right here. Okay, I'll come back to that one in a second. And H is the set of the 5 least positive integer multiples of 2, which is that one. Okay. So why is this the null? What does this mean? Well, it says in set builder notation, it says the set of all x such that x is an even integer greater than 4 and less than 5. Well, the only number greater than 4 and less than 6, I said 5, greater than 4 less than 6 is 5, which is an odd number. So that means there are no numbers that fit that description, and the way you represent a empty, it's called an empty set, is you either do this little circle with a cross through it, or you do a brackets with nothing in it. So you could represent, G could also be shown as like this, and I didn't do as nice a job that time. So that would be, those two are equivalent, the null set or a set with nothing in it. Okay, I'm not going to assign any homework out of that section, so we'll see you next Wednesday.